Hey, this is Jeremy Schulman, and today we're going to go through a exercise in using regular expressions to parse out, a common example from a switch CLI output, which is what you see here on the right, and convert it into a JSON dictionary, structured data. So this particular example, I'm going to demonstrate a couple of techniques that I use when I have to do this type of processing. So this is not going to be like a basic introductory to regular expressions, but I am going to cover some basic topics as we go along. So the first thing I want to kind of show you is we've got essentially a summary table at the top, or a set of summary fields here up at the top, and then we have essentially a table of data here on the bottom. This is kind of a common structure of output you might see on a CLI. It's not always this case, but this is the particular example that I'm going to go through. And then what you can kind of see on the left side is after I've parsed it, I've kind of picked out the particular summary fields that I want, and I've created key values for those. And then for the set of interfaces, I've created a list of dictionary objects, and in each of those I've converted each row in this table to a dictionary object. Now what you can see here is in each of these dictionary objects I've converted what I'd call the short name to the long name, and in some cases these records have VLANs, for example here, and in some cases they don't. So you'll see some records have VLAN ID of null or none. This is a JSON dump. And some of them have their VLAN IDs here. So this is what we're going to do. I have a demo working, so if I actually click the play button or the run button here, you can see it kind of runs in real time. And what we're going to do is kind of break this apart step by step. So I'm going to get started with that, and we will go to a demo work in progress. So let's just start with nothing, and if I switch over here to demo work in progress and hit play, you can see, let's get started. All right, so the first thing we're going to do is we're going to import a few standard libraries. So the first one is the regular expression library, and if you want to get documentation on the regular expression library, the best place to start is the Python documentation, which is here. And I'll put these links in the bottom of the video. And I'm definitely not going to go through all of this material. I'm going to kind of go through some of the bits and pieces that we're going to use, but this is essentially the reference page for everything about regular expressions in Python. And then there is a playground area where if you want to practice regular expressions, they have different languages, and here's Python. RegEx 101 is the one I particularly use. There's a bunch of these out there, but this is always a great place to try it out. Okay, and I'm using pycharm here, pycharm Professional, which has a couple really cool features that I really like using for doing regular expressions. Okay, so the first one is the regular expression library, and the second one is I need to import this text data. So this is a file that I've got, and I'm going to use the pathlib library. So I'm going to say, let's call this my CLI output is going to be, I want to pull in the path data, so this is my show PTP text, and I'm going to read the text in. So that's just basically going to read the contents of that file into this string. This is going to be one big string, and once I have that, I could say, print CLI output just to show this to you, and if we run this, we can see, what we have in the file is what we get in the output. Now, one of the fun things of having a IDE like pycharm is you can make breakpoints. So, I'll show you that, and we'll kind of debug code as we go along. Now, the first technique that I like to do is break apart the content into these separate areas. So we can see that we've got this table here, and then the summary fields up here. So I want to split the string into two parts, and to do that, I want to know where essentially this line starts, because above this line I'm going to take out the summary fields, and below this line I'm going to have the fields of the table. And that's pretty straightforward to do that. I can say, table starts I'm going to create a variable that indicates where the table starts, and I'm going to use the CLI output, and I'm going to find, where I get, this string. Oops. Where I find this string. It doesn't have to be specific, but I know that in this output, this is, kind of where I want to look at. And what find does is it's going to give us a position in the string where it finds this substring. So if I put a breakpoint here and I click run with debugger, what I can see here is that the table starts at position 599. That means basically 600 bytes into the string CLI output is where it finds this line. Now, why is that important? Well, when we start using regular expressions, we have to tell it where to start and stop when we look through strings, because we don't want to, parse areas of the string that are not of interest to us. So, for example, when we're looking to parse out these summary fields, we don't want to look through the string that's, after this position in our content. Okay. So the first thing that I'm going to do then is I'm going to map out the summary fields that I want. So let's say that I want the boundary clock, the grandmaster clock ID, the number of slave ports, the number of master ports, the actual slave ID or the slave port name, and the current time. So I don't want all of them, I just want some of these. Now the way that I'm going to go about doing this is I'm going to copy and paste each of these lines and convert them into the regular expressions that I want. So let's say I'm going to create a variable called lines to match. So this is going to basically be a list of all the lines that I want to match. Now I could create this as a list, or I could create this as, in this case, this is going to be kind of what's called a generator, because I'm only going to go through the list once, but it's still kind of a sequence if you want to think about it. Now what I do here is I'm going to use regular expression compile, and I'm going to take the content of the line that I want, and I'm just going to drop it in here. Now, from this line, what we really want is the PTP mode. So we're going to take this part of the content and we're going to turn that into a set of parentheses, which means we want to capture the content that comes in this area of the line. And basically what we want to do is we want to capture everything to the end of that line. So in this case, I'm just going to say a dot star, because that's going to capture everything to the end of the line. And I'm also going to use some flags here called RE multi-line. Now, this is the first line in the text of this content, so technically I don't need this, but I'm just going to use this flag over and over again, and I'll explain why in a minute. So I'm going to repeat this process for each of the lines that I want to capture. So there's this one, and this will be RE compile, and this is going to be essentially, now what I could do is, instead of doing dot star, I could, because this is just a whole bunch of characters, I could say I want to find everything that is a non-space. So here this /s is a character code that is documented in the regular expressions. So let's take a look at that. We can see /s here matches any character which is not a white space character. Okay? And the dot character that I used before here is any character, because in this case what I'm looking for is basically anything, whether or not it's a word or a space. I'm just going to the end of the line. But here I'm saying after I see the word grandmaster clock identity, I want to capture everything that is, a non-white space character. Now I could have used dot star here as well. And the difference between plus and star is any character or one or more characters. So here I'm going to say dot plus, which means I expect at least one character. And same here, I expect at least one, so this is one or more characters. And again, I'm going to set this flags equals RE multi-line. I also want to denote that this starts at the beginning of the line, so I'm going to use the caret symbol, which indicates that I'm looking for this word that begins at the start of a line. So I'm going to do that process again and again and again. So now, because you can see, like, we want to look for this, we're going to skip this line, we're going to skip this line, and then we want to find this line. The reason why we use RE multiline is so that we can process this text and kind of skip lines, or we want to process multiple lines looking for the pattern that we're going after. And so that's why we use RE multiline here, because we're processing multiple lines of content looking for the pattern that we want to find. So let's do this again for RE compile. Oops. This, we're going to say number of slave ports. And start a line here. Now again, this is a number, so if we wanted to be specific, we could say I want to have a digit. So /d is a digit. So if we looked here, we could see -d matches any Unicode decimal number. And that's what a D is. And then capital D is, not a decimal digit. So the character patterns that are matched are usually lowercase to match something, and then capital of that letter to not match that something. All right. And we'll do multiline here. And we want to find the number of master ports. So we'll follow what we're doing here again. Boop. And then flags is RE multiline. And we'll do the same thing here. So /d plus. And then we're going to get the slave port. So RE compile, start a line. Now this is a word, so we're going to say /w plus. Flags RE multiline. And we're going to skip a whole bunch of them and then just go to the current time. Current time. Okay. Compile, last one, start a line. And then, since this is a bunch of characters and a bunch of white space, I am once again just going to do dot plus and flags equals RE multiline. Okay, so now that I've got this, basically the fields, the lines that we want to match, what I'm going to do is I'm just going to run through a for loop, right? I'm going to say for, try match in lines to match. And here what I want to do, I want to take this try match and I want to use this method called search. And what that does is that this allows us to search the string that we're going to give it using the pattern that was compiled already. So I'm going to say search, and then the string that we want to look at is, of course, the CLI output. And what search is going to return to us is what's called a match object. So I'm just going to say MO here. And then I'm going to say print MO just to print it out. So let's see what happens when we just run this code. So we can see that we get a whole bunch of match objects, which is good because this tells me that our regular expressions are processing. So I can see here's PGP mode and Grandmaster mode and number of slave ports. So we can see that we're matching what we want. Now I'm going to put a breakpoint here so we can see these one at a time with a little bit more detail. I'm going to run this in debugger mode. And you can see I've got my match objects here. And here is the pattern that we found. And here is the string that it matched against. And what we want to look at here, this match, we can actually evaluate the expression. I could say MO, and I could say groups. And it's telling me that the match object, right, because this is a capture group, it found boundary clock, right? So that's the content that we're trying to capture. And that's what these parentheses give us. This is a capture group. And if I continue this, and we do it again, I can see that in this case, what I found is in this case, this is the Grandmaster clock ID, right? So the groups is what allows us to pull out what we want. And if I said group 1, you can see it's just going to give me the value. This is because this is the first capture group. it's going to give me that result. And if I do group 0, that's going to show me the entire string that was matched. So these capture groups are a very important concept when it comes into regular expression processing. So here again, we can see like this is capture group 1 because this was the first and only capture group. Now, I like to name my capture groups because it's easier to process, and then there's a technique that I'm going to show you why in a little bit more detail. But you can name a capture group so that it's just not a number here. For example, we can name a capture group by starting off with a question mark and the letter P and then an angle bracket to name the capture group. So let's say I call this PTP mode, and I'm just going to do a couple just to show you this technique. And I'm going to call this one Grandmaster Clock ID. Okay, so let's rerun this. And let's look at our match object. And in this case, what we're going to do is we could say match object, and then we could say group 1, right, boundary clock. And we could also use something called a group dict. And this shows us that this is a dictionary that has the key PTP mode, and the boundary clock is the value. Right now, this is going to be an important concept because what we really want to do is we want to find all of these fields and create a single dictionary composed of all of those fields. I think you can even do group, and in this case, we call it PTP mode. Yep, and I think you can even treat the match object with a get item, and you can say, in this case, it is PTP mode. So you can kind of see that, you can pull the capture group by name in a couple of different ways here. You can use it by number, you can use it by the group dict, you can use it by the group, the name, or even using as a get item mechanism. Okay, so what I'm going to do is I'm going to kind of do the same thing for the rest of these. I'm going to name these. So this one is going to be slave port count. I'll use _C to mean count. And here is the capture group for master port count. And this is going to be the capture group for slave port, and this one will be the current PTP time, so I'll just call this current PTP time. Okay, so now what we have is all of our capture groups set up, and if I were to print each of those out, so I'll say print mo group dict, and then run this, run, what you're going to see is I've got, each of those match objects is giving me a dictionary, each with a key and a value. Now what I want to do is I want to combine all that together. So let's say that I want to just start building up my dictionary object. So let's call this, toDictionary is going to be dictionary of content, right? And this is going to be the end result. So this is, converting all of the CLI into my dictionary. I'm going to do the match object, and then I'm going to say toDict update, and then I'm going to pass that the group dictionary. Okay, so what that does is it's going to take this dictionary and update toDict with the contents of that. So it's essentially merging all these little dictionaries into the one big dictionary. And we can see that if I just print it out. So I'll say import JSON, and then I can say JSON dump toDictionary, and I want to send it to standard out, and I want to indent that 3 spaces. Okay, and now if I run this, what you can see is I've got one dictionary now, and you can see how the fields have all been merged. Okay, the other thing you should see here is that the slave port count, these are strings, but we want them as numbers. So if we wanted to, convert them into numbers, we have to do that part a little bit manually. So we could say, to dictionary, and in this case, slave port count. We want to turn that into the integer of that thing. And same with the master port count. And we'll just copy and paste that. Oop, here. And we can run this again, and we should see that these are now integers. Okay, great. Now, as we're kind of looking at this, and we look back at the text, every time we're doing that regular expression search, we're always starting from the top of that string. We're doing the search. So the first one searches, it finds it here. The second time we do it, it starts again at the top and then finds the content here. And then the next time it starts again at the top and it then finds it here. So, this is a small bit of text and it's not really a big deal, but there is a way to optimize this algorithm. Now, the search method allows you to pass parameters for the start and the end of the search. Now remember, we know what the end should be. We should stop looking where the table starts. So this should always have an end position of table start, because we don't really want to search the content into the table for these summary fields. And even though it didn't create an issue in this code as we run it, why should we want to tell regular expression to search into content we don't care about? There's another field where it says where to start. This pause is where do you want to start looking. So the first time that we want to start looking, we want to start at position 0. So pause equals 0. And if we put pause equals pause here, right? This is basically going to do exactly what it's doing currently, right? It's going to start every search from the top of the string CLI output. But let's say we don't want to do that. Let's say that we want to start searching after the thing that we just found. Well, it turns out the match object will allow us to know where it found that string, the substring match, and it will tell us where that substring ends. So we can kind of look in the next search following the match that we just found. So again, I'm going to put a breakpoint here, and I'll show you this. So here's our match object, and you can see pause is where we started. End pause is where we're telling it to end. But if we evaluate the expression mo end, and this is a method, we can see that its end was at position 24 in the string. So if I were to jump back to the string and go put my cursor here at the end of the string, we can see that this value is 25, right? So this is 24 and this is 25. So what I'm going to do then, just to optimize this code, not because this is a small example, but I want to show you the technique. We could say once we have found the match, then we want to change our starting position equal to the matched object end plus 1, right? So at this point then, we're basically doing the next search where the previous one left off. And I get a bug. Boop, boop, boop. Why do I get a bug? It says keyboard interrupt. Oh, let's do this. Run. Sorry. I was doing a run with a breakpoint. Okay. So here you can see the content is the same as we expect it to be. All right, very good. So this is showing you a couple different techniques, how to search from the last thing that you found, how you use match groups with names, and how you can, look through content, skipping over multiple lines. The only drawback to this approach that I've done here is that, this order of lines to match has to be in the order of this content. For example, if, for whatever reason, if these lines got reordered, then this code using this pause trick or technique, it wouldn't work anymore. But again, it's a small thing in the grand scheme of things. All right. So now we have all of our summary fields. The next thing that we want to do is start going after our lines of content. So what we're going to do is I'm going to capture just one of these lines, and I'm going to, again, kind of do the same thing. I'm going to create a variable called row match, and I'm going to compile an expression. And here, this is the line that we're going after. So what we can see is that there are some number of spaces, a word, some number of spaces, another word, and we really don't care about the rest of this. So what we can do is turn this into some number of spaces, which is s plus, right? And I know that because I'm going to go here, and I'm going to see S matches Unicode white space characters. So that's going to match any kind of space. And then I'm going to put in, for now, a capture group. And I'm just going to say anything that isn't a space. Right? And then I'm going to say anything that is a space. And then anything that is a word. This is a word. That's really it. I don't really care about the rest of this. So I'm going to name my capture groups. So this is going to be PTP port status, because that's what that was. And this first one was the name. So this is going to be interface name. And that's what we have, interface name and interface status. So let's go and use this row match. And in this case, what we're going to do is we're going to row match and find all. So find iter is another method of regular expression, and what it says is I want to find every occurrence of this regular expression, in the content that we give it. So here we can say the string that we want, and here we could also do, pause and end. So for us, pause, where we start, is going to be where the table starts. So we're going to say pause is equal to table start. Now I'm just going to set a breakpoint here, just so we can see what this is. I'm going to comment that out, and we're going to run this. And we have row match. Oop, I needed to set this to a variable. So we'll call this rows is equal to row match find, and we'll run this again. Okay, so what is rows? So I need to go to the next. Let me go to next. Step over. Actually, I meant to put the breakpoint here. So let me start over. Okay. So there should be a rows variable. Oh, this says I got an exception. And it says that the missing argument was string. I forgot to pass what we're searching for. What we're searching, obviously, is the CLI output, but we want to start that CLI output where the table starts. So that was my bad. Okay, so now we should have rows. Now, rows is what's called a callable iterator. So it didn't give me the list of all the matches because this is returning me an iterator, and as I iterate through them, it's going to give me the next. But if I wanted to see all of them, I could say list all of my rows and hit return. And it will tell me hey, these are all the ones that I found. These are all the rows that we found. So putting that into say an output, we could do something like this. For row in match rows, print row. Now that's going to give us a match object again. You can see we've got all these match objects. And in some cases we've got this VLAN thing showing up, and we have to account for that because some lines have VLANs and some don't. What I'm going to do is I'm going to break this apart just to make this a little bit more readable, because you can do that. So I'm going to leave that there, and I'm going to break this up. So I can see, like, this is my interface name, and then I'm going to put this as a start of line, because it needs to be a start of line there. And then what we could do is x equals 1, and I'll put a breakpoint right here so we can kind of see this, and I'll run it again. And what are my variables? Debugger, variables. Variables, show variables. Nope, oh, sorry, not that. All right. Where are my variables? Debugger. And oh, it says it finished. Oh, that's right. I need to like make it break here, and so I have a stopping point. Oh, signal 11. Interesting. All right, let me put the breakpoint here. Try it here. Right. All right, let's see what's going on. I am finding each of these things, and it is not stopping on my breakpoint. So why is that? Find this. Oh, because I did not compile it with multi-line. So flags RE multi-line. Right. Let's try again. Okay. That's demonstrating why you need RE multi-line, because I am matching multiple lines one after another, because this table has multiple records. Okay, that kind of makes a lot more sense now. So here's our match object, and if we do MO groups, we can see that there's one match. Oops. Sorry, I'm looking at the wrong variable. I need to look at row groups. Oops. Okay, so we can see that the first thing that we found was ET9, and the second group match that we found was master. And we could do the same thing with group dict here, and we can see that IF name is ET9 and the port status is master. Now, if we go through this a couple more times to the point where we might see a VLAN, let's see what happens. So what I'm going to do is I am just going to say print row group dict and just let that run so we can see what it looks like. Okay, so you can see, this all looks fine until we get to an interface that has a port status, and now it says VLAN. I'm like, well, that's not right, because what's happening is it's picking up this content before it picks up this content. And so what we have are rows that have optional content, and so we need to encode that into our regular expression. And the way that we do that is you can say, for example, I am going to follow this interface name with some optional content. I'm going to put this optional content on the next line just to make it a little easier. And so that optional content is the word, is a comma, followed by the word VLAN, followed by a number, right? So comma, a space, the word VLAN, a space, and then the number. So I'm going to actually put inside of here another capture group with this /D for a digit, and I'm going to name this capture group VLAN ID with the letter P. The other thing I really like about pycharm is it's actually parsing this content as a regular expression, and it'll show me where it's an error. So when I forgot the P, it's telling me, hey, there's something wrong here, and that's because I forgot the P. Okay, so now if we run this again, now what we've got is it's only showing us the items that have the VLAN ID in it because we're saying we want to match this expression. So if we want to make this expression optional, you just add a question mark at the end. That makes it optional. That makes this entire capture group from the outside, the outside capture group, which contains this content, optional. So now I'm going to run it again, and now we can see that I have a mistake somewhere because now I am back to where I was. So let's see, that's that, that's that. Okay, so this is an optional VLAN followed by some spaces followed by PTP port status. So this is where we get into debugging the regular expression. Right, that is optional. So what am I missing? Space, so this is followed by spaces, some number of spaces, followed by that. Okay, so I'm going to cheat and look at my working example. And S plus, W plus. Okay, so that's what I had before. So we're going to put the, just to have what I had before, S plus is here. And this is W plus. So this is what I had before, S plus, when that's right, and then VLAN ID, right, right, okay. So what am I missing here? What is different? Oh, that I had, this should be, oh, W plus, I think. Yes, okay. Because this was this was the character class for non-spaces, it was actually eating that comma before. So now, because this is a word match slash W, it would not eat that comma. So that's a good, that's a good kind of thing going on here. I'm demonstrating that. You got to be careful about what character match sequence you're using because slash S or slash capital S was anything that isn't a white space, which would include a comma. All right, so now we're back to, we can now see all of the content, and we can see VLANs that show up as matching. We've got all of our matching content here. However, we still need to do two things. We want to expand this port channel or Ethernet interface from these kind of like this short prefix to a long prefix. So I'm going to show you the next technique to do that part. But before I do that, I'm going to add these rows into an interfaces dictionary of our toDict. So this is going to be toDict interfaces is going to be a list. And what we're going to do is we're going to append to that interfaces. This is just a way to do a shortcut, so I don't have to keep referring to toDict interfaces over and over again. I could say interfaces append, and then if I do our print, we can kind of see where we're at. Okay, so we're almost back to the end of what we're trying to accomplish, except we haven't expanded this interface name out to Ethernet, and we haven't converted our numbers from strings to integers. Okay, so So basically, what I would do here is I would make, essentially a transformation function to say, we'll take this content and transform it before we use it. So let's say I made a function called row transfer form, and what that's going to get is it's going to take, from a row dictionary, and it's going to return a dictionary. I'm just using type hinting here just to, show what this looks like. So what we would pass is row transform, and we would pass it the dictionary that we just got. And just to make this kind of simple, let's say VLAN ID, we can say, if there was a VLAN ID, then what we want to do is turn it into an integer equals the int of that. And then we just want to return the row. So basically, we're transforming it in place. And if I run this again, we can kind of see that, okay, yep, sure enough, we've converted that to a number, and in the cases where it's null, it's not converted to a number. Now, this bit of code here can get simplified a little bit when you're using a modern version of Python. You could say if VLAN ID is equal to that, so I'm capturing it as a variable. I could just say, now that I know what it is, I could do something like that. And you don't need parentheses apparently when you're doing just one. So this is what's called the Walrus operator. So I'm just basically saying, if VLAN ID, which comes from this dictionary, if it exists, then I've got that value and I can just stick it back in there. Pretty simple. Now the next thing that we want to do is do this conversion of name prefixing. So what we want to do is a string substitution based on a value. And in this content, we really only have two types of interfaces, ET and PO. Now you could have like a whole bunch of them, like 10 gig, 1 gig, gigabit, but just for the sake of this demonstration, we've just got ET and PO. So the way we go about doing this is, let's say we have an interface prefix, and we'll make a dictionary. This is going to be our translation dictionary. We're going to say ET goes to Ethernet, and PO goes to port channel. So that's the transformation that we want to do. So regular expression, kind of comes to the rescue here. We can do a regular expression substitution, and the way that works is I could say if prefix, I'm going to make something called expand. Well, I'll do this step by step, and then I'll kind of compress it into how I do things. So we'll call this RegEx, and we're going to say recompile. And what we're going to do is we want to search for these prefixes. So what we're going to do is we want to search for either Ethernet or PO. So I'm going to say join, and then if prefix. So what this is doing is it's saying I'm going to create a regular expression that is ET or PO. So because when I run this join over this dictionary, it's just going to give me back the keys. And then the next thing I want to do is I'm going to use that to substitute a replacement. So there's this function called sub, and we're going to provide sub. What we want to match on is the row dict interface name. So that's the input that we want. And if we look at the regular expression documentation for sub, this is the substitution function. And what's interesting here is the replacement parameter. It says if replacement is a function, it is called for every non-overlapping occurrence of pattern. And we're going to take advantage of that because what that function is given is the match object. So I'm going to create a function right here called ifExpand, and we're going to give it a match object, and what it's going to do is returns a string. That's what that replacement function does, and this is a RE_match object. Now, I am going to just put a breakpoint here, just so you can kind of see what's going to happen. So we're going to say replacement is equal to if_expand. That's the function. And I think I have to say string is equal to that. Okay, so here I'm saying string is equal to what we want to search for, and the function that it's going to use for replacement is going to be this replacement, which isn't going to do anything because I want to put a breakpoint here, at least for right now. And so we look at here, and we're going to run this with a breakpoint. Okay, so we hit that breakpoint, and so let's look at this MO, right? This is the MO. And if we look at underscore MO groups, MO group 0. Okay, so you can see that what matched as MO group 0 is ET, right? ET is what was found, in the string, and what was actually matched, you can see what the string was here, ET9. That's the whole thing, right? ET9. So what we want to do is we want to take group 0, the value of group 0, which is ET, and we want to use it as a key into IP prefix to return Ethernet, right? So what this function is doing is saying, given the match object that matched, return back the thing that you want. So what we really want to do is we want to say return if prefix, and then we want to do the MO group 0. And that is what is going to return us back our string. So this function here gives us the if name as a long name, and then we could say row dict if name is equal to if name. So that's basically expanding the short name to the long name and then setting it back into the record. And then if we run this, we can see we've got the name that we want, Ethernet 9 and port channel 4. So it expands it all the way out. So this is a very common trick when you're dealing with CLI output where you have short names and long names to deal with, and you want to try to normalize the short names to their long names. And I've written code that has a whole series of short names like GI, TE, TW, all of those types of things. So this basically accomplishes the goal of this kind of tutorial. We've taken this content, we've pulled out the summary fields that we want, and then we processed a table of data below. I am going to show one more slightly advanced technique that kind of does this whole little process here a little bit cleaner. It's more of an intermediate topic or technique, but I'm going to show it to you because it's what I do, and I think it's a cool thing. What you can do is you can see how this IP prefix sub here is passing in this if_expand function. Well, we could, rather than having this function here defined and kind of doing all of this, we could build it all at once, and we could call this function if prefix regular expression. We could just call this if prefix expand, and what we want to do is we want to take the result of this compile, which is a match expression. We can say, well, I want to call sub by default, but we want to bind the replacement method or this process at the time that we're creating this variable. And the way that you do that is you use a method from functools, and this is what's called a partial. So we're going to create what's called a partial function, and really the purpose of a partial function is to, quote, default a parameter. So I'm going to say partial. The way partial works is you give it the function that you want to add a to default a parameter. So in this case, what we want is we want to default REPL. All right, so we would say REPL is equal to, now I'll do this in 2 steps. Let's do this. I would just call this func, just to keep these 2 things different for the moment, and I'll call this func. Okay, so what's happening here is if prefix expand is now a function that is going to use the substitution and use this as the replacement. So now what I could do is I could just say if expand, and then I am just passing it the string, and I don't have to pass anything more. So it makes this part of the code a little bit easier to understand. It's like, okay, I'm expanding this, and I don't have all that other stuff hanging out here, and I can basically just do this. Okay, and if I run this, I can see I get the same result, right? Which is great. Now we can take this one step further and get rid of this function altogether, because I could use what's called a lambda expression, which is just an inline function, and then I can copy and paste this here and even get rid of that function. So you can see at this point I'm creating a new function, because that's what partial returns, that's based on this regular expression patterns sub-function, where I'm binding the replacement as this lambda function. So yeah, you're looking at that and going, okay, if you showed me that first, that would be really weird. But hopefully, as we've gone through this step by step, you can see, how that all works. All right, so I'm going to stop here because, gone on probably much longer than you wanted to see this. But I did want to show these techniques. I think that, they're handy in a lot of different, use cases and applications. There are, pre-built libraries in Python for regular expression processing. One is called text FSM, and another one is called TTP. Both of them are really great for what they do. They do require you to kind of learn their syntax and grammar and usage. So I wanted to show kind of the foundations of just using the standard Python library. So I hope this has been, helpful. I hope you learned some stuff. And if you have any questions, just please let me know. Thanks.